Online people, can you please confirm me my voice is audible or not?
Yes, we can hear you.
Okay, and hope you are able to see my screen also.
Yes.
Okay, thank you. Thank you for confirmation. Good morning all. So actually in the yesterday's session, we discussed about features of big data or cloud. So what are the different features we are having? First one is scalability. Second one, high availability. And third one, replication. Next, distributed framework or distributed tech. Next one is fault tolerant or fault tolerance. And next one, move computation. And last one is partitioning. So move computation and partitioning we haven't discussed in the yesterday's session, but we discussed about the scalability, high availability, replication, distributed tech, and fault tolerance. So what is meant by scalability? By depending on the requirement, if we are going to increase number of resources or if we are going to decrease the number of resources, that we can call it as nothing but scalability. Just will quickly recap this. So for example, we are using the 4 different laptops and all these 4 laptops are connected to the same network. Now we are trying to load the 1 GB data by using the distributed framework technology. So if you are going to if you try to load the data for 1 GB data, what we discussed yesterday, your data will be distributed to across all the laptops or all the systems. For example, it is taking 0.25 GB data here, and here 0.25 GB data and 0.25 GB data and 0.25 GB data across all the laptops. Your data is distributing, right? Now my requirement is I want to retrieve the data from all these systems. My requirement is I want to retrieve the data. But if you want to retrieve the data from all these 4 labs for 4 laptops, for example, currently it is taking 5 minutes of time. But now my requirement is I want to retrieve all this data within 2 minutes only. That is my requirement. So what we discussed yesterday, what we can do here, what we can do. So, and just I'm adding one more thing here. So for example, this is having the 8 GB RAM. So each laptop is having the capacity of 8 GB RAM. So with the help of the 8 GB RAM capacity, when we are trying to retrieve the data, we are able to retrieve the data in 5 minutes. But now requirement is I want to retrieve the data within the 2 minutes of time. So what we can do here, first option, what we can do, instead of 8 GB RAM, simply we can able to increase the RAM capacity within the system. For example, here I am going to increase the capacity as a 16 GB. And here also 16 GB, here also 16 GB, and here also 16 GB. Now, once we are going to increase the RAM capacity, so automatically what will happen? Now, if you want to retrieve the data, will it take the 5 minutes of time or will it take the 2 minutes of time? Automatically within 2 minutes only we can able to fetch the data, which is nothing but indirectly by depending on the requirement, we are increasing the resources or we are increasing the capacity of the system. Within the system we are increasing or out of the system we are increasing? Within the system only we are increasing. Now tell me this kind of scalability, what we can able to call? This is nothing but we are calling it as a vertical scalability. So whenever we are going to increase resources or whenever we are increasing the number of resources within the system, that kind of scalability only we can call it as nothing but vertical scalability. Okay. Now, for example, I'm taking the same example again. So what I'm doing here is instead of increasing the RAM capacity, what I'm doing here, I'm increasing the number of laptops as part of the second example. Now, here we are having total 8 different laptops. and all these are having 8 GB capacity. Okay, now if you are going to distribute the, if you are going to load 1 GB file in this kind of system, now in each and every laptop, how much data it is going to take? For example, I'm giving 0.13 GB data in each and every laptop. Your data will be distributed. So how much amount of data it is distributing? It is distributing only 0.13 GB data. But now how many laptops we are using? As part of this example, we are using total 8 different laptops. Your data distributed across the 8 different systems only. See, actually, instead of calling it as a laptop, I can call it as a VM, which is nothing but virtual machine. But so far you don't know about what is the meaning of VM. That's the reason I am not using all those terminologies. For our easy understanding, I'm saying that laptop. So some real-time employees immediately will think that why is our calling it as a laptop instead of calling it as a VM? Because so far we haven't discussed about what is the virtual machine, how it is going to use in the real time. That's the reason I am not using all those terminologies. Slowly we'll enter into each and every topic only. But for now, try to understand, instead of calling it as a virtual machine, we are calling it as a laptop. Now in this second example, what we are doing, instead of increasing the RAM capacity, we are increasing the number of laptops as part of within my distributed framework. That's the reason here also, if you are trying to load the data for 1 GB, what is happening? Your data is loading across all the laptops, but instead of taking the 0.25 GB data, it is loading the 0.13 GB data in each and every laptop. Now, if you are going to perform the retrieval operation here, within how much time it will fetch the data? It will take 5 minutes or it will complete within 2 minutes only. Here also your data will be retrieved within 2 minutes only, because now we are having the more number of systems. From the more number of systems, parallelly we are going to retrieve the data. That's the reason here also you can able to retrieve the data within 2 minutes only. Now here we are increasing the number of resources, but we are increasing the resources within the system or outside the system? Outside the system. Now this kind of scalability, what we can able to call? This is nothing but horizontal scalability. So this kind of scalability only we can call it as nothing but horizontal scalability. Whenever we are increasing number of resources within the system, that we can call it as a vertical scalability. Whenever we are increasing the number of resources outside the system, that we can able to call it as nothing but horizontal scalability. Is clear? Okay. Now in the same way, yesterday we discussed about replication. What is meant by replication? Any answers? Yesterday we discussed about this, right? So see, for example, we are loading the 1 GB data. For example, just for example, I'm saying that we are loading ABCD values. In the first laptop, it is loading A, second laptop B, third laptop C, and fourth laptop D. Now, for some reason, this laptop is crashed. So what will happen? Automatically you are going to lose the complete data which is present in the laptop 3. So which is nothing but, if you are not going to maintain any kind of backups here, whenever any VM or whenever any laptop or whenever any system is going to crash, you are going to lose the whole data. So to overcome that, in the big data or in the cloud computing systems, what they're doing here, they are providing the option called as a replication factor. So what is the meaning of replication here? Whatever the data is present in the laptop 1, same data will be copied to other laptops. Whatever the data present in the laptop 2, same data will be copied to other laptops, and laptop 3 data will be copied to other laptops, and laptop 4 data copied to other laptops. Now once the data is distributing like this into the other laptops or other virtual machines also, now because of some reason my laptop 3 got crashed. Now in the laptop 3, what is the data we are having? C data. Now if it is got crashed, where we can able to, from where we can able to fetch the data? Either you can fetch it from the laptop 4 or laptop 2 or laptop 1. So this kind of feature only we can able to call it as nothing but replication. Because of any reason, if any virtual machine is going to fail, no need to worry about the data. We can able to fetch all the data from the other virtual machines, because here we are using the feature called as a replication feature. Because of having the replication, if any system is going to crash, automatically we can able to fetch the data from the other servers or other virtual machines in our real-time system. That kind of property only we are calling it as nothing but replication property, or we can call it as a replication factor. Now yesterday we discussed about one more thing. By default, what is the replication factor we are having in the big data? By default it's 3. Now by depending on our requirement, can we able to change the replication factor? Yes or no? Obviously yes. We can able to change it by depending on the requirement. Okay, so this is the one more topic we covered in the yesterday's session. In the same way, we discussed about one more property, high availability. What is meant by high availability? At any point of time, if system is going to available, which any point of time in the sense 365 days, 24/7, if system is going to available, such kind of systems only we can able to call it as nothing but high available systems only. So what is the example we can able to say for this? Our UPIs and Twitter. So coming to Twitter also, as we discussed yesterday, it is given the high availability for only 99.99% only. So complete 100%, none of the systems are going to provide the high availability. 0.0001 possibility there is chances for non-high availability. But if we are going to get the 99.999% availability, such kind of systems only we can able to call it as nothing but high available systems. In the same way, we discussed about one more topic called as distributed framework or distributed tech. What it means? As part of distributed systems, what is going to happen? All the work will taken care by a single person, or that work will be distributed to the multiple persons. Whenever we are distributing the task to multiple people, or whenever we are distributing the task to the multiple systems, such kind of activity only we can able to call it as nothing but distributed activity. Whatever the framework is supporting such kind of activity, that framework only we can able to call it as nothing but distributed framework. In the previous example, if you remember, as part of scalability, I told you 1 GB data is loading into all the laptops. Indirectly, what we can able to say here, your data is distributing or not? Your data is distributing across all the virtual machines only. So whenever we are distributing the data, or whenever we are distributing the task in the real time, that kind of activity we can able to call it as a distributing activity. Whatever the framework is supporting that kind of activity, that framework only we can able to call it as nothing but distributed framework. Okay. Yeah, one last thing, fault tolerance. What is meant by fault tolerance? What is meant by fault tolerance? So we are having the multiple servers in the connected network. Because of any reason, if one laptop is crashed or one virtual machine is crashed, now what is going to happen? If one server, for our understanding, I will add it as here, server 1, server 2, server 3, and server 4. So we are having the multiple servers in the network. Because of some reason, one server got crashed. Okay. So here what is going to happen? Whenever one server is going to crash, automatically other server will come into the picture. It will take care of all the responsibilities of the first server. That kind of feature only we can able to call it as nothing but fault tolerance feature. Now after some time, for example, this server is up again. Then what will happen? Then server 2 and server 3 will take care of their independent task automatically only. So whenever server 3 is got crashed, automatically server 2 will take care of all the responsibilities of the server 3. After some time, if server 3 is up again, then what will happen? Server 2 and server 3 both will take care of their independent activities. So that kind of feature only we are calling it as nothing but fault tolerance. But tell me here, for this fault tolerance or high availability or distributed or scalability or replication factor, as a person, are we doing any activities manually here? No need to do any activities manually here, because these are the default features we are getting in the big data, or these are the default features we are getting in the cloud computing. That's the reason nowadays most of the companies are migrating to the cloud systems or our big data systems. Okay, all these are already we discussed in the yesterday's session, but just by giving the examples in the diagrammatic way, I am trying to explain about all these topics. Is it clear? Just 1 second only. Okay, now we'll discuss about one more property called as a partitioning.
Sir, I have a question.
Yeah, please ask me.
Sir, for my understanding, like this fault tolerance, and there was a replication factor. These things are similar, kind of like there in replication there was a one node fail, so we retrieve data nearby node, and in fault tolerance, there one server failed, our secondary server will take care of that part.
Mhm.
These are the similar kind of things.
Now see, coming to replication factor, what is happening here? So actually someone is asking the question, replication factor and fault tolerance looking like same, because in the replication factor, what is happening? I'm telling, if one laptop is going to crash, we are going to fetch the data from the other systems. In the fault tolerance also, what I'm saying here, if one server is going to crash, we are going to, other servers are going to take care of the responsibilities of the server 3 in this example. Okay. Now you tell me, so replication factor and fault tolerance, both are same or both are different? Both are same. So whomever is asking the question in the online, he is thinking that replication factor and fault tolerance both are looking same, but you people tell me, is it same or is it different? Coming to replication factor, what we are talking
Different,
about
sir.
the data. We are not talking about the activities what we are doing in the servers. And so in the servers, what we will do, we will store the data. At the same time, we are going to perform some computational tasks. Okay. So here what we are dealing, whenever we are given the replication factor, it is dealing with the only data. It is not dealing with the computational tasks only. But coming to fault tolerance, what I'm telling here, if server 3 is going to crash, server 2 will take care of all the responsibilities of the server 3, which is nothing but here it is going to take care of the data, or it is going to take care of the server 3 computational tasks. It is going to take care of the tasks which are performing the server 3. All those tasks will be taken care by our server 2. That kind of property we are calling it as a fault tolerance. But coming to replication factor, we are not talking about the task. We are talking about the data. If one system is going to crash, from other system we can able to get the data. That property we are calling it as a replication factor. By considering that, we can able to say both are not same, both are completely different. Is it clear? Whomever asked the question online?
Yeah, got it.
Okay, thank you. Yeah. Now
So,
coming to
sir, basically, in that replication factor, our we copy data we take as a different server, na? We are not taking that copy of this data as the same server, or we take as a different server.
yeah, we are so actually, so when I'm calling it about the different laptops, as I told you earlier, all these are the different VMs, or we can call it as all these are the different servers only.
Virtual machine. Okay. So we take copy of data for different virtual machine, or it's same?
No, we'll take the copy of this data into the different virtual machine, not in the same virtual machine.
Different. Okay, got it. Thank you.
Okay. Yeah, thank you. Now next one is partitioning. So based on your understanding, any idea what is the meaning of partitioning in the general words?
Just splitting the work.
Chunks of data, I think.
Yeah, whenever we are dividing the data into the multiple chunks only, so that kind of property we can able to call it as nothing but partitioning property. So whenever we are dividing the data into the multiple chunks, that kind of property we can able to call it as nothing but partitioning property. Okay, now for example, I am trying to load 100 employees information. So what I'm doing here, I'm trying to load 100 employees information. For example, here I'm having the employee ID and I'm having the one more column called as a country column, and we are having some data like this. So because of rains, yeah, sorry. Actually, I got a call. So for that reason, I stopped discussing about the topics only. Yeah. So actually, so here we are loading, for example, 100 employees information. So we are just I'm giving the example as 8 employees, and all these employees are working in the different countries, for example, like this. Okay. Now I am trying to load this data as part of my loading process. Now, without enabling the partitioning property, if we are going to load the data, what will happen? Yep. All this data, for example, is loading into the single laptop. Now you tell me here, we are loading the data for 8 employees. All this data is loading into the single laptop system. Now here, can we be able to get the proper performance? Just here I'm giving the example as a 8 employees, but just think that we are loading the 1 lakh employees information. If we are loading all the 1 lakh employees data into the single laptop, so or single virtual machine, we are having the multiple virtual machines, but we are loading all 1 GB data into the single laptop or single virtual machine. Now here, can we able to get the good performance, or we are going to get the bad performance? Obviously we are going to get the bad performance, because here we are maintaining multiple virtual machines, but we are loading all the data into the single virtual machine. For example, if you are having the 1 GB data, if you are loading all the 1 GB data or 1 lakh employees information into the same single virtual machine, automatically what will happen? Your performance will be degrade. That's the reason here we are going to enable the property called as a partitioning property. So once we are going to enable the partitioning property, what will happen? This entire data will be dividing into the multiple chunks. At the same time, all this data will be loading into the different laptops. For example, now what is happening indirectly here? Instead of loading all the records into the single system, we are loading the data into the multiple systems. In this example, earlier I am saying that we are loading all the data into the single virtual machine. Even if you are having the multiple virtual machines, even you are having the distributed framework, if it is loading all the data into single virtual machine, automatically we are going to get the bad performance, right? Now, instead of loading the data into the single virtual machine, what is happening? We are chunking the data, and that data is loading into the multiple virtual machines. Andy, now tell me, compared to the previous one, now we are going to get the good performance or not? Automatically we can able to get the good performance. Indirectly, instead of loading all the data into single virtual machine, we are chunking the data and we are loading that chunking data into the multiple virtual machines. Because of that reason, now we can able to get the performance we can able to get the good performance automatically. But tell me here, still I have one more question. Now, for example, I'm writing a small query. Select star from employee table where country is equal to US. Or so if you don't have any knowledge on the SQL query, so forgot about the statement. Now my requirement is, from this system, I want to retrieve the data for only US related employees. Now you tell me from where we need to get this data. From this whole system, I want to retrieve the data for only US related employees. So what is going to happen? See, it will read the virtual, it will scan the virtual machine 1. It will try to understand whether it is having the US data or not. It will try to scan the virtual machine 2. It will try to understand whether it is having US data or not. Here we are having the US data. It will take this record. Then it is going to read the data from the virtual machine 3. We don't have any records. It will read the data from the virtual machine 4. Here we are having US related data. It will take this data. But tell me here, in this process, what is happening? Actually, US employee data is present in the only 2 laptops, but as part of retrieving the data for US employees here, unnecessarily what we are doing, we are scanning entire system, right? We are scanning the virtual machine 1, virtual machine 2, virtual machine 3, and virtual machine 4. Unnecessarily, we are scanning the whole data or whole virtual machines. Again, because of that reason, it will take the more performance. Now, for example, instead of spreading the data like this, what I will do here is, I will spread the data like this. So what I'm telling here, instead of spreading the data like this here, what I'm trying to do, I am trying to load the data like this in all the virtual machines. So what is the difference between this one and this one? Here, I am taking the country code. All India related employees I am loading into the virtual machine 1. All Australia related employees I am loading into the virtual machine 2. All US related employees I am loading into the virtual machine 3. All UK related employees we are loading into the virtual machine 4. Indirectly, what we are doing here? We are grouping data based on the country. That data we are loading into a particular virtual machine. Now, what is the advantage if we are going to load the data like this? What is the advantage if you are going to load the data like this? Now, for example, I am trying to retrieve the same US employees data. Now, tell me what is going to happen. Whether we need to scan all the virtual machines, or can we be able to scan only virtual machine 3? In virtual machine 3 only, we are having all the data. So don't think about by seeing only small data here, and we are dealing with only 8 records. But if you are going to work in the real time, we are going to work on the millions of the records. Okay, you are going to work on the lakhs of records or crores of records. In the situation, if you are having the US data across the multiple virtual machines, it will take good amount of time for the purpose of retrieving the data. But instead of that, if we are going to store one particular country data into the one particular virtual machine. Now, what is the advantage? If you're trying to retrieve the data for US country data, it is going to the virtual machine tree. It will fetch the data for only US country data from the only virtual machine tree. Instead of scanning all the virtual machines, here what is happening? It is scanning the data from only single virtual machine. With that, it will give the data in the very fastest way. So this kind of activity only we are calling it as nothing but partitioning. Now you tell me, here I am calling this is the partitioning. I am calling this is also partitioning, but what is the difference? Earlier I said that this is partitioning, chunking the data, loading it into the multiple virtual machines. Here also I'm saying that this is also the partitioning, but what is the difference between this partitioning and this partitioning? See here we are doing the partitioning without depending on any column or without depending on any value. So what we are doing here, we are doing the random partitioning, which is nothing but in every virtual machine we can able to see the different countries of data. That kind of partitioning indirectly we can call it as nothing but random partitioning. We are partitioning the data randomly, not by depending on any particular column, not by depending on a particular value. We are doing the partitioning activity. So that kind of partitioning we can able to call it as nothing but random partitioning. But coming to here, on what basis we are partitioning the data?
Column.
Based on which column we can able to say? Based on the country code we are doing the partitioning. Particular country data I want to load into particular virtual machine, which is nothing but we are doing the partitioning, but we are doing the partitioning based on a particular column. So that kind of partitioning we can able to call it as nothing but key level partitioning. That kind of partitioning we can able to call it as nothing but key level partitioning. So indirectly we can able to say we are having the two types of partitioning. One is nothing but random partitioning, other one is nothing but key level partitioning. What is the meaning of key here in this example? Your country is nothing but one key. Okay, by using this kind of key level partitioning we can able to get the good performance. If you go back to the first one, partitioning, what I told you, we are loading all this data into the single laptop. Instead of that, if we are going to perform the random partitioning, we are going to get the good performance. Now compared to random partitioning, in the key level partitioning we are getting the good data, good performance or not? This is level 1,
Yeah.
this is level 2, this is level 3. In the level 1 we are not getting the proper performance. In the level 2 we are getting the proper performance. But coming to level 3, compared to level 2, in the level 3 we are going to get the more performance. And so this is the way we can able to understand how chunking is going to happen with the help of the partitioning. But coming to here, in this Excel sheet I am typing everything manually. But if you are going to work in the real time, or if you are going to work in the cloud system or in the big data system, are we doing any activity manually? No, just we need to define what is the partition column you want to use. So I will define my partition column is country. Once we are going to define the partition column as country, automatically your big data system or your cloud system will load the data based on the country. Your data will be spreading across all the virtual machines in the partition manner. We are not going to perform any activity manually here. Just we need to define which column you want to give it as a partition column. Once we are going to define the column as a partition column, automatically based on the partition column, your data will be distributed to the multiple virtual machines. That kind of property only we are calling it as nothing but partitioning property. Now overall tell me, with the help of the partitioning we are going to get the good performance or bad performance? Definitely we are going to get the good performance. Compared to random partitioning and key level partitioning, by using which partitioning we are going to get the good performance? By using the key level partitioning we are going to get the good performance. Now you tell me, you are working in the real time projects, you want to enable the partitioning property, you will enable this one or this one? We are going to use key level partitioning as part of our real time system. So by using the key level partitioning only we can able to get the good performance. That's the reason if you are going to enable the partitioning property, definitely we are going to use the key level partitioning as part of our real time system. Okay, now you tell me, if you want to follow the key level partitioning, do we need to follow any kind of rules or not?
Definitely.
So for example, I want to follow the key level partitioning. I am giving my partition column as an employee ID. Now tell me what will happen. I want to go with the key level partitioning and I'm giving my key column as an employee ID. What will happen?
So
in the employee ID column, we are having the unique records or we are having the duplicate records? We are having the unique records. on top of this unique column, if you are going to apply the partitioning, what will happen? This data will not be distributed equally into all the systems only. But coming to here, what we are discussing in the country code column, we are having the duplicate records. All India duplicate records will load into one system. All Australia duplicate records are storing into one system. All US duplicate records are storing into one system. But if we are going to define the key column on the employee ID, what is going to happen? Here we are having all the unique values. In the situation, your data will not load equally into all the systems. Because of that reason, you cannot able to get the proper performance even if you are going to enable the partitioning property. For that reason, whenever you want to enable the key level partitioning, we need to define the key column which is having redundant data. So what I'm telling here, we need to define the key column. What is the rule we need to follow? We need to define the column which is having the redundant data. In the country column, you tell me, are we going to have the redundant data or not? Definitely we are going to have the redundant data because multiple employees can able to work in the same country. That's the reason there are the chances for redundant data in the country column. That's the reason we can able to go ahead and use this column as a key partitioning column as part of our real-time system. Now, for example, tell me.
So, sir, in real-time system, these random partition and key level partition, these kind of properties are in real-time system.
Yes.
We can.
That's the reason only we are discussing, right? So in the real-time system, we are in the big data or in the cloud, we are having the partitioning property, but without defining from our side, your system can able to understand automatically based on which column we need to do the partitioning. In the big data or in the cloud system, we are having the partitioning concept, but your system automatically cannot able to understand. I need to do the partitioning on the country column or I need to do the partitioning on the employee ID column. We need to define. But once you define which column you want to do the partitioning, then loading of data by using the partitioning, your system will take care. But as a user or as a developer, you need to define based on which column you want to perform the partitioning activity. Once we define that, automatically your system will take care of the data loading process by performing the chunking operations based on the key column. Okay. Now tell me, for example, here we are having the one more column called as a gender column. And now total we are having the 3 columns. Now out of these 3 columns, which column is the best column to give it as a key partition column?
Gender.
Gender. Okay, 1 second. So in the gender, generally we are going to have male and female. Okay. Now just I added some data for understanding purpose. Now by seeing the data, try to give the answer. Which column is the best column to define the partition column as part of our key level partitioning?
Sir, basically a little bit confusion are there. Like this key level partition and random partition, these kind of properties system take care by itself, or these kind of properties we can configure?
Yeah, that's the thing I'm telling. See, so for example, you enable the partitioning property. If you are not defining any column in the partitioning property, then what will happen? As I told you earlier, by default, it is going to perform the random partitioning. So online people are asking the question, Andy. So do we need to give this kind of information? Our system will take care of this information automatically. What I told you before few minutes, we need to enable the partitioning property. So once we are going to enable the partitioning property, for example, if we are not defining any column in the partition property, then what will happen? It will take it as a random partitioning by default. Your data will be distributed automatically without depending on any column. But here we are enabling partitioning, but are we going to get the good performance? No. Now, for example, I am enabling the partitioning. At the same time, I am giving the partitioning based on a particular column. Indirectly, what we are doing? We are enabling the key level partitioning, which is nothing but there is no separate property called as a random partitioning or key level partitioning. And we are having the property called as a partitioning. But if you are going to enable the partitioning without giving any column, that partitioning we are calling it as a random partitioning. If you are enabling the partitioning by giving a particular column, that partitioning we are calling it as a key level partitioning. If you are not giving any column, your data will be distributed randomly. If you are giving a particular column, then your data will be distributed in the equal way by depending on the country column in this example. This is the way we are calling it as a random partitioning and key level partitioning. Now you tell me overallly, as part of this one or this one, are we doing any activity? We are doing only one activity, which is nothing but we are enabling the partitioning property. What is the second one we are doing? We are defining on which column you want to perform the partitioning operation. If you are given the partition column information, that we are calling it as a key level partitioning. If you are not giving any column information, that we are calling it as a random partitioning.
Okay, so without given any column, how we can do partitions? Basically, in partition by we need to define column name. So
see, that's the
without
thing.
column,
That's the thing I'm telling, that if you are going to enable the partitioning property, if you are not giving any column, what will happen? By default, your system will take care of any one of the column, and based on that, it will perform the distribution activity. Is it clear?
yeah. Basically, how we can do without
Yeah, how we
without
can do
given
that, we are
column?
going to cover as part of our practical session Sunday. So here we are discussing about the theoretically. Okay, so you are saying that
Okay,
partition by
okay.
column name. So you know about the partition by property in the SQL side, or you know partition by property in the
Spark.
database side. So but coming to here, other people are not aware of partition by, how we are going to use in the SQL side. So without knowing about that, if I'm going to start discussing about the partition
So
by keyword,
yeah,
people will
got
get
it,
the
sir.
confusion.
So if someone question me some there was a how many types of partition, so I need to tell random partition or key level partition or static or dynamic. What I can answer?
So coming to here, you can able to say this as a random partitioning and key level partitioning. So you are saying that static partitioning and dynamic partitioning. And so I hope you are having some knowledge on the other topics also. But if you try to bring all those topics here, people will get the confusion. Okay, so in the coming classes, we are going to discuss about what is static partitioning, what is dynamic partitioning. So here, this is the problem with the some of the people. So you people know about all the concepts already, might be you learnt already or you worked on those already. But if I'm going to start discussing about all the topics at that level, other people will get a lot of confusion and other people will get the disturbance. That's the reason we'll discuss about all these things slowly. So at
Okay,
present,
okay.
try to understand. So random partitioning and key level partitioning. In the coming classes, we are going to discuss about what is the static partitioning, what is the dynamic partitioning, how to enable the static partitioning in the SQL side, how to enable the dynamic partitioning in the SQL side. All those topics we are going to cover as part of our coming classes. Don't worry about all those things.
Okay, okay, got
Is it
it,
clear?
got it.
Okay.
So these kind of you differentiate data in physical level, or it's like is divided data between different nodes, like one country data in one side and second country data divided by country data, like so it in real time it's divided into different nodes, or it's
That's the one only we discussed, right? So data will be loading into the multiple nodes. What is the question you are having? I didn't get that. So you're asking the question
how
whether data will.
how data is divided, like yeah, in partition by data you write the data is divided like country wise.
Okay.
In real time,
So
how?
in the real time, it is going to use the hashing algorithm. Okay.
Oh, got it, got
Or
it,
it is
got it,
going to use the round robin algorithm. So by using this kind of algorithms, your data will be distributed into all these nodes automatically. So coming to here in this Excel sheet, I am putting
got it.
everything manually. Okay. But in the
Yeah,
real
yeah,
time, are we doing this activity manually as I told you earlier? No, your system will take care of all these activities automatically. But internally, how it is performing all these kind of operations with the help of the hashing algorithm or with the help
yeah,
of the round robin algorithm, your data will be distributed to all the nodes automatically as part of our real-time system.
got it.
Data distribution we are not involving. Okay, your system will take care of that. But
Yeah, yeah,
just
got
what
it,
is
got
the
it.
one of the input we are giving here? We are giving the partition column as the one of the input. By depending on the partition column, internally by using the hashing algorithm or by using the round robin algorithm, it is going to perform the distribution activity automatically by taking care of your system. But don't ask me again what is the hashing
Yeah,
algorithm
thanks,
and
sir.
what is the
Thank
round
you
robin
so much.
algorithm
Got it.
only. So those topics we are going to cover as part of our coming classes. So here we are purely focusing on what all are the different features available in the big data side, or what all are the features available in the cloud side.
Got it. Thank you, sir.
Okay, no problem. Now coming back to this example. So if you observe here, we are having the three different columns in this table. Now, based on your understanding, you try to give the answer. Which column is the best column to define the key level partitioning? So someone is saying gender column. Tell me, is gender column is the best column to define the partitioning? If I am going to define the gender column as a partition column, it is having the redundant data. I agree about that, because we are having the so many male values, we are having the so many female values. Might be some people are having the question, what is meant by redundant data? Redundant data is nothing but if any particular column is having the duplicate values only, that kind of data we can call it as a redundant data. Now in the gender column, we are having the redundant data or not? We are having the duplicate values for M. We are having duplicate values for the F. Okay. But if we are going to apply the partitioning on this column, there is a problem. What is the problem? all these M values will be loading into, for example, first virtual machine. All these F values will be loading into the second virtual machine, because we are defining the partition column on top of the gender. In the gender column, we are having the redundant data, but how many different values we are having? Only two different values. One is the M and one is the F, which is nothing but all M values are loading into virtual machine 1. All F values are loading into the virtual machine 2. Now you tell me, with this kind of distribution, can we able to get the complete performance? You will get the performance, but can you able to get the complete performance? How many virtual machines we are having? Actually 4, but your data distributed to how many virtual machines? Only 2. Unnecessarily, we are not using these 2 virtual machines, which is nothing but you are having the capacity of the 4 virtual machines. But because of given the partition column on the gender, what is happening here? Here it is system is able to use only 2 virtual machines for the purpose of loading or for the purpose of retrieving. Now with this, can we able to get the good performance? Obviously no. But for example, if I'm taking the partition column on top of the country, now what will happen? Now in the country
Okay.
column, do we have the duplicate records or not? India is a duplicate record, Australia is a duplicate record, US is a duplicate record, UK is a duplicate record. Now all this data will be distributed to the multiple virtual machines. Here all India data is coming here, all Australia data is coming here, all US data coming here, all UK data is coming here, which is nothing but if we are given the partition by on top of the country column, your data is distributing to all the virtual machines. But coming to gender, what is happening? Your data is not distributing to all the virtual machines. And by seeing this example, you try to give the answer. Which column is the best column to define the partition column here? We can able to say country column is the good column to define partitioning. Okay, so I am given the rule as define the key column which is having the redundant data. By thinking that don't go for, if any column is having the duplicate, go for the column as a partition column, and it should be redundant, but it should not be more redundant. Okay, coming to gender column, it is the more redundant column, but coming to country column, it is redundant, but it is having the less redundancy. So we need to go for the redundant column which is having the less redundancy in that system. So based on that column, we can able to apply the key level partitioning. So which overall I can able to say defining the partition column is the one of the important activity in your real-time project. If you are given the wrong partition column, automatically what will happen? As part of loading, it will take good amount of time. As part of retrieving also, it will take the good amount of time. But tell me, in the real-time project, who will define which column we need to take it as a partition column? In real-time projects, who will define which column we need to take partition column? Any guesses?
Cloud data engineering. I mean,
Can
who
we
is
take?
retrieving
Can we
data?
take our own definition? Can we take our own decision? Someone is saying
Well,
the cloud
based
data
on
Based on the
engineer.
requirement. Based
Based
on the
on the, yeah,
requirement.
based on the requirement, as a cloud data engineer, can we take our own decisions? Obviously, answer is no. Only in the real time, we are having the people called as either data modelers, or if data modeler was not there, we are having the data architect. So they are going to define you in this table. This column you need to take it as a partition column. See, for example, here we are discussing the simple example employee table. You know about the employee table, you can understand what is the employee ID, what is the country, what is the gender. But if you are going to work in the real time, are we going to work on employee table and department table? Obviously no. You are going to work in the some new tables which is related to that particular domain. In the situation, you cannot able to understand what is the meaning of employee ID, or what is the meaning of country, or what is the meaning of gender. For example, I will give one column as a underwriter ID, and I will give one more column as a underwriter name. Now you tell me what is the meaning of this underwriter ID, underwriter name. Can you able to understand what is the meaning of this? No. Without knowing the meaning of underwriter ID and underwriter name, can we define which column we need to take it as a partition column as a cloud data engineer? It's impossible, right? That's the reason I'm saying that in the real time, as a cloud data engineer, we are not going to take our own decision to define which column is the partition column. Then who will define? Our data modelers or data architects will define which column we need to take it as a partition column. Based on that, just we are going to define the partition column when you are going to create the tables, or when we are going to perform the SQL operations, we are going to apply the partitioning on top of that column. So simple statement, as a cloud data engineer, we are not going to define which column is going to act as a partition column. Your data modelers or data architect will define which column we need to take as a partition column as part of our real-time system. Is it clear? Okay. If you see here, yeah.
Small note అంటే పార్టిషనింగ్ ఉంటుంది సార్. పార్టిషనింగ్ చేసినప్పుడు మనం ఆల్రెడీ డిస్ట్రిబ్యూటెడ్ ఫ్రేమ్వర్క్ ద్వారా 4 సర్వర్స్ లో డేటా పెట్టాం. సో అది కాపీ కూడా ఉంది. సో అది ఫస్ట్ సర్వర్ రీడ్ చేసినప్పుడే 4 సర్వర్స్ డేటా ఫస్ట్ సర్వర్ లో ఉంటుంది సార్. ఐ మీన్ బ్యాకప్ తీసుకోవడం వల్ల. అంటే ఇప్పుడు బ్యాకప్ తీసుకున్నాం కదా సార్ సెకండ్ సర్వర్ ది, ఐ మీన్ ల్యాప్టాప్ బి యొక్క డేటా ల్యాప్టాప్ ఏ లో కూడా పెట్టుకున్నాం కదా మనం, ఒకవేళ క్రాష్ అయితే టాలరెన్స్ కోసం. సో పార్టిషన్ చేసినప్పుడు ఈ సర్వర్ రీడ్ చేసినప్పుడు ఆల్రెడీ దీంట్లోనే మిగతా 3 ల్యాప్టాప్స్ యొక్క బ్యాకప్ కూడా ఇందులో ఉంది కాబట్టి ఇందులో రీడ్ చేస్తే ఇంకా కాస్ట్ అవుతుంది.
No. See, so someone is asking the question. So whenever we are going to enable the replication factor, what we discussed earlier, so this laptop, so these 2 records are storing in the laptop 1 and laptop 3 and laptop 4. But tell me here, that is the backup data, that is the actual data.
Yeah, backup data, but
so if you see this example, so here we are saying that this B data is distributed into laptop 1 and laptop 3 and laptop 4 only. Now this is the actual data, this is the backup data. This is the backup data. Whenever I am going to retrieve the data from the laptop 1, you tell me it will retrieve the data for A or it will retrieve the data for ABCD here.
Yeah, it will
retrieve only actual data. It won't retrieve the backup data whenever we are going to perform the retrieval operation. But whenever this laptop is going to crash, then only this data will be acting as a actual data. Otherwise, this data is not going to act as a actual data. Till that time, it is going to act as a only backup data as part of our real-time system. Yeah, please continue your question now.
Yeah, I mean, నేనేమడుగుతుంటే ఇప్పుడు పార్టిషనింగ్ చేసినప్పుడు అది వెళ్ళి రీడ్ చేసుకుంటుంది కదా సార్ ఈ సర్వర్ లో ఉన్న డేటా. సో అది రీడ్ చేసినప్పుడు ఈ సర్వర్ లో ఆల్రెడీ దీంట్లోనే మిగతా సర్వర్స్ డేటా కూడా ఉంది కాబట్టి ఇక్కడే మొత్తం రీడ్ చేసేస్తే, ఐ మీన్ దానికి ఖచ్చితంగా ఈ ఒక్క పర్టికులర్ గా నేను ఏ డేటా స్విచ్ చేసి మళ్ళీ బి సర్వర్ కి వెళ్ళి అక్కడ.
Yeah, you're asking the same question again. Just try to understand here difference between the actual data and backup data. Now, for example, as per our statement, if it is going to fetch all the records of the laptop 1 or laptop 2, if I'm going to run the select star from the table, or if you're going to retrieve the data, will it give the 4 records or it is going to provide all the 16 records?
4 only.
4 only, right? So which is nothing but whenever we are going to perform the retrieval operation, at any point of time, it will deal with the only actual data. It won't deal anything with the backup data. Even if you are going to perform the partitioning operation also, what is going to happen? It won't deal anything with the backup data. It is going to deal everything with the actual data. Now in this example, I'm saying that whenever we are defining the partitioning on the country column, in every virtual machine, we are getting the 2 records, okay? But if there is replication factor is enabled, now what happened? These same 2 records will be copied here, and here also. But is that the actual data or backup data? That is the kind of backup data, okay? Whenever we are going to perform the retrieval operation, it is going to deal with the only actual data. It is not deal anything with the backup data. Even if you are going to define the partitioning also, it will deal everything with the actual data only. It is not going to deal anything with the backup data in our real-time systems.
Okay.
Is clear?
Okay, sir.
Okay, thank you. Any other questions so far on top of this partitioning? So because this partitioning is the one of the very important topic, and in the coming classes, multiple times we are going to listen about the same concept. So when we are going to discuss about the BigQuery, that is the one of the GCP service, there we are going to discuss about the partitioning. When we are going to discuss about the normal SQL queries, we are going to discuss about the partitioning. When we are going to discuss about the PySpark, there also we are going to discuss about the partitioning. When we are going to discuss about the NoSQL, there also we are going to discuss about the partitioning. So this topic we are going to cover multiple number of times in the coming classes. That's the reason this is the one of the very important topic. In the interviews also, definitely you will get one question on the partitioning. What is partitioning? What is clustering? That is a separate topic we'll cover in the later classes. But this is the one important topic from the learning perspective, one important topic from the interview perspective also. That's the reason we spend this much of time on top of the partitioning concept. Still, if you are having any other questions, please ask me on the partitioning side.
Sir, I think there is one concept like data localizations, so that the performance you can increase, right? Instead of searching the data in the
Yes.
other.
Yes, correct.
that also we will cover, right?
Yeah, we are going to cover all those things, but
Okay.
those are things we are going to cover in the later classes, not immediately.
Okay.
Okay. Yeah. Any other questions? Okay. If no
Sir,
questions,
you say this partition kind of things are take care by data modeler. So in real time, if you are doing transformation on like real time transformation, and you need to take you need to create a partition. So I think you are not going to data modeler. Like you take these kind of decision. Like if high cardinality column, you can take. Or you need to confirmation from data modeler.
Yeah, 1 second. So actually, so someone is asking the question. So in the real time, so we are going to apply the transformations. As a data engineer, we are going to apply the transformation. Now, when you are going to apply the transformation, you know which column is acting as what. But tell me here, as a data modeler, when he is going to define any column as a particular column, what is the prerequisite to the data modeler? He need to understand the requirement, right? So he need to understand the requirements. He need to understand the transformations in the project. By considering all those things only, data modelers will take the decision. Okay, don't think that as a data modeler blindly he is going to take the decisions. Only as a data modeler, he will try to understand what is the project requirement, or what is the table requirement, or what is the business requirement, or what all are the different transformations business is expecting. He will try to understand all that information. With that knowledge only, as a data modeler, he is going to define which column we need to give it as a partition column, or which column we need to give it as a primary key column, something like that. Blindly he won't define this column is the partition column or that column as a partition column. He will go through all the requirements in the real time, or he will go through all the business requirements in the real time. With that understanding only, he will define which column is going to act as a partition column, or which column is the best column for this project as a partition column. Those kind of decisions data modeler will take by go through all the requirement documents and by go through all the business requirements and transformations in our real-time projects. Don't think that when I'm saying data modeler will define the partition column, he won't take the decision blindly. He will go through each and every requirement of the project. Based on that only, he will take that kind of decision in our real-time projects.
Oh, got it. So, sir, if in case any scenario we need to take decisions, so we need any kind of confirmation, or we can do?
No, you should see. It's not a kind of a lab system, or it's not a kind of a your own system, and you won't able to take your own decisions. Compulsory, you need to depend on the data modelers and data architect for the purpose of getting this kind of confirmation. Okay. So, for example, if you are for example, data modeler given gender column as a partition column. But tell me, as per our example, is it the good column for partitioning? No, right? In the situation, might be you can have the discussion with the data modeler saying that this is the kind of a this column is having the huge number of duplicate records. If you are going to apply the partitioning on this gender column, it will create the problem. Instead of applying the partitioning on this gender column, if you can apply the partitioning on the country column, you can able to get the good performance. This kind of discussions you can able to have with the data modeler, and after that, based on the data modeler suggestion, you can able to change the partition column in the real time. But without reaching out to the data modeler, can we able to directly take our own decisions?
No.
In the real time, that is not at all acceptable, only because these people are having the authority to define which column is the primary key column or which column is the partition column. If they are defining anything wrongly, and as a data engineer, if you found that that is the wrong column, then what you can do here, you can schedule a meeting with the data modeler, you can have the discussion, you can put all your points with the data modeler, and if the data modeler is agreeing your all the points, then based on that, what we can do here, we can able to change the partition column in our real-time system. All those discussions, all those meetings should happen. Based on that only, we can able to take the decisions as part of our real-time system.
Got it. Thank you so much, sir. In one line, just data modeler profile name.
See, you are asking. See, so someone is asking. This person is asking the question: what is the data modeler profile? But tell me here, this is that question is related to this topic. See, sorry to say this, Sandy. So whenever you're asking the question, please try to link that question to the current topic. With that, what will happen? Other people won't get any kind of disturbance. If you are completely asking any different questions, what is going to happen? You are having the interest, but other people are not having interest for that question. So don't disturb the class. Sorry to say this. So you are asking the question, what is the profile for data modeler? But is it related to our current topic? No, right? So I'm not going in the harsh way, Andy. I am trying to manage all the folks here. If I'm going to give the answers for all these kind of questions, what will happen? Full day we need to spend on the same topic. That's the reason you can ask any kind of question, but please ask the question related to the current topic. With that, other people also can enjoy all your questions. But if you are completely deviating the question, then what will happen? Other people will get the some kind of bore feeling. Other people will get the lot of disturbance. Sorry to say this. Okay.
Sir, regarding that, you are going to cover that ETL concept, right? Are you going to cover the ETL concept by using any tool like a Informatica or something, or generically you are going to cover the?
So yeah, just now I told you, right? So is it related to our current topic?
No, the course content is the ETL concept.
Yeah,
Is
that
right?
we'll discuss at the end of the class only. So someone is asking the question, are we going to cover the ETL concepts or not as part of our classes? Already in the previous session, I think you are the new person. In the previous classes, already we discussed about that. We are going to cover the ETL concepts. We are going to cover the data warehousing concepts. We are going to cover the database
by
concepts
using
and
any
Python
tool
concepts.
or
No, we are not going to use any tools only, because if you want to use the ETL tools, our course will become as a 6 months course.
Okay.
Just we are going to touch the ETL concepts, but we are going to perform the same ETL operations by using the Spark, and we are going to perform the same ETL operations by using the GCP service, GCP cloud platform, but we are not going to use any specific ETL tool as part of our course.
Okay, sir. I got it. That is the one.
Yeah, no problem. Okay, so this is all about the partitioning. In the same way, so we need to understand one more important topic called as a move computation. Any idea based on your understanding or based on this terminology, what is the meaning of moving computation? See, for example, same thing. So we are having again distributed framework. Now in this distributed framework, here we are having the 1 GB data in each and every virtual machine. Okay. Now, for example, you are performing some kind of queries, or you are performing some kind of transformations. Indirectly, we can call we are trying to perform some kind of tasks. Okay. Now, in earlier days, if you are going to use the relational database management system under RDBMS, earlier days, what happened is whenever you want to perform the task, your data is moving to your task, which is nothing but we are having the RDBMS servers. To the server, your data is moving, which is nothing but wherever we are having the server, to the server, this data will be moved, and in the server, all the operations are going to happen. But you tell me, if data is moving like that to the task level, so this, how much data we are having here? 4 GB data. We need to move this 4 GB data to the server where tasks are running. Okay, this is one example. Now, for example, instead of moving the data to the tasks, I will move tasks to data. So first one, I'm saying that moving tasks to, moving data to tasks. So what I'm telling first point, moving the data to the task level. Second one, I'm telling that moving the tasks to the data level. So both are same or both are different? Both are same or both are different? Here, what I'm saying, moving the data to the task, which is nothing but wherever tasks are happening or wherever our queries or transformations are running to the server, we are moving all the data. That is one kind of operation. What is the second kind of operation? Moving the task to the data, which is nothing but wherever tasks are running, we are moving all those tasks to the data level. So both are same or both are different? Both are completely different operations, and moving the data to the task and moving the task to the data, both are two different operations. Now, based on this, you try to give the answer. Which operation is going to provide the best performance here? If we are moving the data to the task, it will give the best performance, or if we are moving the task to data, that will give the best performance. See here, if we are moving the tasks to the data, that is going to provide the best performance. So for example, here you are going to perform the 5 tasks or 10 tasks only. If you calculate from the memory level, for example, if we are going to perform the 5 tasks, indirectly we can able to say we are going to perform, for example, I'm saying 10 KB operation. Now you tell me, moving the 10 KB operations to all this 1 GB data is easy, or moving all this 1 GB data to the 10 KB data is easy? Which one is easy? Moving this 10 KB operation to all this huge amount of data, that is the very easy operation. Indirectly, what we are doing here, we are moving the task at the data level. We are not moving the data to the task level. earlier days in the legacy technologies, if you are going to use the RDBMS and all these kind of things, and your data is moving to the task level. But coming to in the distributed frameworks or in the current technologies, what is happening here? If you are going to use the Spark, your tasks are running on each and every server, and your tasks are moving to at the data level. That operationally we can able to call it as nothing but moving the task to data, or we are calling it as a moving the computation. Why we are performing the queries? To perform some kind of computation. Why we are applying the transformation? To perform some kind of computation. What is the meaning of task? Why we are doing the task? To perform some kind of computation. Indirectly, we are moving the computations near to the data. We are not moving the data near to the task. We are moving the computations, or we are moving the tasks, or we are moving the transformations near to the data. That kind of operations only we can able to call it as a move computation. But tell me again here, to perform this operation, do we need to do any manual activities? It's not required. Your distributed framework will take care of this activity automatically. From our side, no need to perform any kind of activities. If you are going to use the Spark, or if you are going to use the big data, automatically the system will take care of this move computation activity. So because of that reason, again, most of the companies are nowadays migrating to either big data or cloud platform. Okay, so why we are discussing all these things? All these are nothing but different kind of properties we are having for the big data and cloud, and all these properties are given the best performance or bad performance. All these properties are going to provide the very best performance compared to the previous technologies, and that's the reason all the companies are moving to cloud platforms in the current days. Already so many companies are migrated, still so many companies are working to migrate to the cloud. Why they are migrating? If anyone is asking the question, why your project is migrating to the cloud, what we can able to say? Because of all these features, my company or my project is migrating to the cloud. Okay, but to give the statement, first we need to understand about all these terminologies, and so indirectly by using all these things, we are trying to understand what all are the features of big data, or what all are the features of the cloud. Okay, I want to give the pause for 1 minute. Any questions? Again, please ask me here.
Sir, just requesting, could you please tell me again on that moving computation? I'm just
Moving
telling that
computation.
what is moving, yeah. That because whenever you write any query, it is a task. It is go to it is went for data, and it is only searching the data.
Yeah, so see, for example, whenever you are going to write a query internally, or whenever you are going to write a query, or whenever you are going to write a code internally, your entire code will be divided into multiple tasks. For example, task 1, task 2, task 3, task 4. So like this, your data will be divided to the multiple tasks only. So we are assuming that front end we ran only one query, but in the back end, what will happen? In the back end system, your query will be divided to the multiple tasks. That might be 4 tasks, or 10 tasks, or 100 tasks, or 200 tasks, by depending on the complexity of the query which you are writing. Okay. Now what I'm telling here, as part of running all these tasks, these tasks also will be distributed to all the virtual machines. For example, if you are going to run the 10 tasks, what will happen? All these 10 tasks will be distributed to all the laptops or all the virtual machines. And in these virtual machines, what we are having the data. Now with this, what I'm trying to say, your tasks are moving to the data, or your data is coming to the task?
Tasks are going to data. Tasks
are moving to the data. Why tasks are coming to the picture? For the purpose of running the queries. Why we are running the queries? For the purpose of doing some kind of computation. For that reason, I'm saying that computation activities are moving to near to the data, not data is moving near to the computation. Because so this is the high level statement, but whenever we are calling it as a computation, how computation is happening? With the help of queries. How queries are running internally? With the help of the tasks. Where these tasks are running? On each and every server. By distributing it in parallelly, your tasks are running in each and every server. We are going to have the data. By considering all these things, what I'm telling here, your tasks are going near to the data. That is nothing but we are calling it as a move computation. Okay. Still any confusion? Please ask me.
No, sir.
It's clear, right? Okay. So in the coming classes, we are going to discuss about one statement called as a explain plan. So which is nothing but whenever we are going to run the query internally, how it is working, we can able to find out by using an option called as a explain plan. And in this explain plan, we can able to see whenever we are going to run the query, how many tasks it is creating. At that point of time, when we are doing it practically, easily you can able to understand what is meant by task, how it is moving to the each and every server as part of our code execution. But for now, just to try to understand theoretically what we are discussing here. Is it clear?
Yes.
Okay, thank you.
సార్ ఇన్ కేస్ ఒకవేళ ల్యాప్టాప్ 3లో లేకపోతే ల్యాప్టాప్ 4లో సర్వర్ రాలేదనుకో ఇప్పుడు మిగతా 3 దాంట్లలో అయిపోద్ది అది.
Yeah, correct. That's it, right? So earlier what we discussed, for example, so these tasks are running on all these laptops only. So for example, because of some reason, laptop 3 got failed. For example, this laptop 3 is taking care of the task 3. Because of some reason, this laptop 3 got failed, crashed. Then what will happen earlier, what we discussed in the fault tolerance? Whatever the tasks are taken care by laptop 3, automatically all these tasks will be taken care by any other server. That kind of activity only what we are calling, that is nothing but fault tolerance. Okay, by considering the fault tolerance feature, you can able to answer yourself for your question. Laptop 3 is running the task 3 because of any reason. If this laptop is going to crash, then automatically what will happen, other laptop will come into the picture that will take care of all the tasks of the laptop 3. That kind of feature we are calling it as a move computation, or that kind of feature we are calling it as a fault tolerance. That is the fault tolerance. Okay, so this just you can able to link your question with our previous topic for the fault tolerance.
ఓకే సార్.
Okay, yep. Any other questions?
Sir, can you please tell me in this move task to data any example?
This
Any
is the
kind
example I'm
of-
telling you. So if you are going to run the query, it is going to divide the data into the multiple tasks, and those tasks are moving to the multiple virtual machines in the distributed framework.
Okay, and these above moving data to task.
I told you, right? So as part of our legacy RDBMS systems, whenever we are going to run the query, your data is moving to the server. Your tasks are not coming to the data. Whatever the data you're running, so we are having the RDBMS servers, your data is moving to the server. There all the tasks will execute, and based on that only we are going to get the data.
Okay, okay.
Okay, yep. Any other questions so far? Okay, if no questions, yeah, just I want to say, so tomorrow we don't have any class Sunday. So as I told you earlier, so Thursday, I'm either Thursday or Wednesday, I will give the holiday. So Thursday, we don't have any class. And actually, admin team asked me to inform one thing. So please enroll your names with admin team, because today onwards, you will get the notes or links or videos only if you enroll. Okay, so they are going to enable the access for some of the folders in the Google Drive and some of the folders in the Infinity tools and all these things. And so for whom they are going to provide all these kind of options, whomever is going to perform the enrollment, only for them only they are going to provide these things. Indirectly, I'm trying to say, so if you didn't pay complete the payment, so please complete the payment. So with that only they are going to share all the notes or all the meeting links or all the videos. With that, you can able to continue to attend the classes. I think already we spent 2 days for demo and we spent the 3 days of classes. And if you're satisfied, so please enroll as soon as possible, and please give your mail IDs to the admin team. So with that, they will share the links and they will share the notes and they will share the videos. Okay. And one more thing, actually we created one Telegram group. We'll share this link also, whomever enrolled. So please join this Telegram group, Telegram group only. So in that Telegram group, you are going to get the valuable information. If there are any kind of openings, we will share that in the Telegram group. Or if you are having any kind of interview questions, we'll share that in the Telegram group. And if you are having any kind of updates also, we'll share that in the Telegram group. So whomever enroll, they will get that link. So once you are going to get the link, don't hesitate to join. So please join that link. So because in the Telegram group, other people cannot able to see your mobile numbers also. That is the best advantage we are having in the Telegram channel. So whenever you are getting any such kind of link from the admin team, so please try to join the Telegram group to get our regular updates. Is it clear? Okay. And one more last thing I want to say. As I told you earlier, from Monday onwards, we are going to have the 8 hours session. And till now, what we are doing, we are discussing about the basic things and all these features and everything. All these are the basic things. So from Monday onwards, we are going to start discussing about our GCP services, and we will start discussing about DB concepts. So both we are going to cover theoretically and practically with real-time examples. So I know from last 3 days onwards, we are discussing only theoretically only, because as I told you earlier, so still some people are joining 1 day late or 2 day late. So just that's the reason, just I'm not starting any practicals immediately. But from Monday onwards, we are going to have the continuously 8-hour session. And from Monday onwards, we are going to start discussing about our GCP services and DB concepts theoretically. And also you also need to start the practice. Okay. I hope already you adjusted with our system. If you haven't adjusted, please adjust timings and please adjust with our class. Please adjust with our online class. So within 1 week, you need to adjust yourself with all these things. With that, what will happen from next Monday onwards, easily you can able to understand what we are discussing. Easily you can able to perform the practice also, whatever the topics we are discussing in our classes. And as I told you earlier, out of these 8 hours, 4 hours classes and 4 hours practical sessions. I informed this already earlier, but just I'm repeating one more time, Andy. So whatever the 8 hours of classes we are going to have, 4 hours we are going to have the classes, and remaining 4 hours we are going to have the practical sessions. Is clear? Okay. That's all for today, Andy. So any questions from the online people?
Yeah, one question, sir. Sir, Saturday and Sunday, you will have the class, sir. This Saturday, Sunday.
Saturday and Sunday, every Saturday and Sunday we are going to have the classes.
Okay, because this Saturday it's some Moharram, it seems. That's the reason I asked.
Yeah, actually for this Saturday and Sunday we haven't finalized, Andy. We'll confirm you on Friday. For example, if you take the decision by today itself, we'll send that information in the Telegram group, or you will get the message. But so far, we are planning to conduct the classes on the Saturday and Sunday. But if you are planning to give a holiday by considering Muharram or anything, we'll inform you by today EOD or on Friday. We'll inform you about that. Is it clear?
Yes, sir. Thank you.
Okay. Any other questions? If any people join newly, any questions, please ask me. Offline people, any questions? Okay. Yeah, no questions. Thank you all. We'll meet on Friday.